Hello, everyone. You are welcome. Thank you so much for joining this session. It is wonderful to have you on board. Now, my name is Dr. Sandra Powers, and I'm bringing before you today the topic of robotics. We are going to construct the robotics use case diagram. We're still in the business of trying to model the entirety of AI. Of course, all of this had started several days ago. We're now into day 4 of our internship series. It's a free series, videos available on YouTube, and then paid for, available for 40 days. And the intention is to take people from zero to hero and get people from knowing absolutely nothing about artificial intelligence to being supreme experts, the go-to experts, in fact, SMEs, subject matter experts in whatever company you find yourself in. Now, up to now, we have handled a number of topics. We have been able to make a start from a few days ago, and we started with making the case for the AI domain. We now understand better what AI is. We understand the various branches of artificial intelligence. We have started to paint a picture of various elements of the artificial intelligence equation. And so up until now, we have been able to put together a picture that has been thus far. I just want to put on this presentation very quickly so you can see the type of progress we have made. We've been able to go through the AI mind map. We've been able to look at the AI industry landscape to understand which industries, sectors, and domains have an appetite for implementing artificial intelligence solutions. And what has happened is that on a one-by-one basis, we have started looking at the package diagram and use case diagram as part of design work for the artificial intelligence. And the rationale for why we have done things the way that we have really is because up until now, particularly on projects, consultancy engagements inside the country and outside the country, myself and my various faculty members have found it very difficult to get optimal, maybe because artificial intelligence is still such a new area. It's very difficult to get analysis level, domain specialist level deliverables and artifacts that paint or tell the sort of story that we want to tell. And so, as a veteran of over 20 years in systems analysis and development, I have started unpacking and unpicking artificial intelligence. A lot of the projects I've been working on lately have been robotic process automation, artificial intelligence, machine learning. In fact, part of the benefits to be derived from what we are doing in this series, internship series, is that we are making available source code for over 60 projects available different types of AI projects that straddle NLP, that straddle vision, that straddle speech, that straddle machine learning, that straddle deep learning. We have a repository of currently over 60 projects, chatbot projects, live chat projects, off-the-shelf projects, Google Dialogflow objects. We have a myriad of source codes that we can make available to you that you can use to actually not just learn with, but use to prove yourself on the shop floor. Now, so far, I've unpacked several aspects of artificial intelligence, but starting from the most simplistic before I make my way to the most difficult, it's no use just getting involved in the mathematical equations or the coding without getting you to appreciate the uniqueness of each aspect of the AI domain. So far, I've been able to help you understand the use case diagram for artificial level domain. You can see it involves machine learning, it involves NLP, it involves speech recognition, expert systems, managing, planning, scheduling and optimization, robotics, the implementation of robotics, and also the processing of computer vision. In addition to appreciating that 100,000 feet picture of artificial intelligence, what I have also carried on doing, myself and faculty team members, is unpacking each domain one diagram at a time. This is computer vision. You can see the use case diagram that we've put together. This diagram can be used in a meeting setting, in a workshop elicitation session. It can be given to the trainer, it can be given to the tester, it can be given to C-level management to be able to very quickly understand. After all, this is the entirety of the system in one diagram. When we begin to decompose each of these use case ellipses, each of the actor notations, when we begin to understand the preconditions, normal flows, abnormal flows that sit within the computer vision use case diagram, what you see in front of you may end up being a document that has over 100,000 pages to it. It is not a small feat to be able to produce a document that sits at 100,000 feet picture. We call it the cloud level, something that experts, something that in-house teams, regardless of whether they are front of house, middle office or back office, or whether they are C-level or heads-off level, everybody can use a use case. Everybody can translate a use case. Everybody can understand a use case. So we've done that for the computer vision domain element of artificial intelligence. We have also done that for where are the others? We have also done that for NLP. This is the NLP one. Done that for NLP. The facilitation of natural language processing includes, the need to understand natural language, classify natural language, generate natural language, facilitate machine perception, and also manage human-computer dialogue using a number of NLP, natural language processing frameworks, tools, libraries, and systems. And so we have also painted a picture for NLP. And so it's my intention, if I go back to this diagram, just to quickly orient you to why we are doing what it is we're doing before we go to VISIO and break and begin to document the robotics use case diagram. This is the AI mind map. You can see it's got 1, 2, 3, 4, 5, 6, 7. Out of the 7, I've done natural language processing with you. I've done a computer vision with you. Today, I'm going to be doing robotics and speech I've done those two, robotics and speech. That's what I want to do with you today. And so the tool we are going to be using for this exercise is called Microsoft Visio. Let me tell you a little about Microsoft Visio. Microsoft Visio is a tool that is used by a number of different professions, different domains, different experts. They use Visio to put together diagrams, notational elements, documentation for work. And part of those that use the Visio tool, Visio is also a Microsoft tool. It's part of the Microsoft suite. In the same way you have Microsoft Word, Microsoft Excel, you also have Microsoft Visio. The Visio that I have in front of me is on a free trial basis. I believe that you can get free trial for 30 days to Visio. It helps you, it enables you, it gives you the ability to be able to start right. You can make your mistakes here without necessarily making your mistakes on the shop floor with the team. So very cheaply, you can also practice, plug in and play with us. As part of what we also do for our internship series candidates, people that sign on for either our 10-day program or 20-day program. With 10-day program, you get 20 days access to our repository of tools. For the 20-day AI masterclass series, you have access for 40 days. And so you can either choose to come and taste and go, or you can come and fully engage for 20 days. In 20 days, will take you from knowing absolutely nothing about artificial intelligence to knowing enough to be able to cast your CVs out and get that job, and then also keep that job. This job is not just theoretical, it's also practical. We force you to get your hands dirty. We encourage you to get your hands dirty. There's no way you can do artificial intelligence at a delicious remove. So part of being on board our 10-day challenge, our 20-day challenge, is that you have ample time to get it right as far as the practices are concerned, so that by the time you get those rich plummy roles, those nice paying jobs and contracts, you do not fail on client sites. You have done the failing here. You have understood the concept here. You have understood the propositions here. You have no need to go and make a mistake on client side. And mistakes are very rarely forgiven, especially when you are a contractor. Your first week is your week of grace. If for that, you may just have 1 or 2 days, and thereafter they expect you to be running at 1,000 miles per hour. You cannot tell them, having secured that job in the middle of a pandemic, that you don't know what you're doing, or that you need to go and refer to XYZ. You don't have that time. You have been paid as a solution provider. You've been paid to come on board and give teaching and give know-how and expose better ways of working, better approaches. And so this is where we give you the opportunity to pick up skills, pick up techniques, pick up tools, pick up methodologies, and then that when you go on client sites, you can deliver effortlessly. So this is the mind map. What we're going to do today is we're going to start with the robotics. So let's go to the diagram. This is the diagram. This is called Visio. And you can see that there are some tabs at the bottom here. The first one that I have done with you has been the AI use case domain. I did that originally in Lucidchart. Lucidchart also another tool. And in this instance, I exported it too. I lifted the material from Lucidchart into Visio because I believe Visio is a better palette. Visio is great. Visio allows you to document the system in so many different ways. Visio permits you to use UML. UML is a de facto most acceptable notational modeling language in system development and in technological projects. And UML has 13 or 14 different ways of representing diagrams. It can be a structural diagram, or it can be an interaction diagram. Basically, a structural diagram could be a class diagram, a deployment diagram, a package diagram, an object diagram, a component diagram, a profile diagram, or a composite structure diagram. An interaction diagram could also be called a behavioral diagram, such as activity diagram, use case diagram, the state machines, and sequence diagrams, communications diagrams, interaction diagrams, and timing diagrams. They give you the ability to tell the story of an event by event change in state story. It allows you to tell the story of changing in state of the system interaction. So we have structural diagrams you can put together using UML. You have behavioral diagram. Well, use case diagrams are part of the behavioral diagram set. So what we are going to do today is hit the ground running. I've opened up a tab. I'm going to call that tab Robotic. So AI Robotics UCD, to keep the naming convention like the others. Yeah. So AI UCD, and I will be putting together this use case diagram. Before I venture anymore, this is where I believe I need to now tell you one or two things about robotics as a domain space. What is robotics? Why is it? How is it? When is it? Who does it? Why is it important? What use cases have come from that? Why is it key in the technology and in the engineering of artificial intelligence to consider robotics? What makes it a viable proposition in an AI project? How come people know to use robots in a project? I want to explain one or two things. Number one, what is robotics? Very simply put, robotics is when we use machines to perform tasks. Robotics is not AI. AI is not robotics, but you can extend AI by robotics. Robotics is that branch of engineering, that branch of technology that is focused on concentrating on constructing and operating robots. So robotics is just simply the engineering of robots, the construction of robots. You know, robots are programmable machines that can autonomously or semi-autonomously carry out a task. Robots use sensors to interact with the physical world. They use cameras to interact with the physical world. Just like the humans need eyes to see, robots have sensors to sense and have cameras to see. Remember, we spoke a lot about this during the computer vision session. You need to roll it back to a few videos to see that. So robotics is a very welcome development in the world of artificial intelligence. It's not quite artificial intelligence, but it is given rise to in a situation whereby you want to deploy machine to perform a task. Remember, artificial intelligence is all about the engineering and the science of getting the machine to mimic humans. Human speaking, human tasks, human thinking, human behavior. So robotics has become huge in the factories of the future, in the type of factories that people like Ocado want to build, in the type of factories that people such as Amazon wants to build, there is the case to be made for robotics. It has the potential to reduce operational costs. It increases productivity through a 24/7 utilizations, as in the robots don't go to sleep at all. As far as these robots are also concerned, they minimize errors or delays or human-generated delays. They eliminate mundane tasks. Collaborative robots eliminate mundane tasks. They increase employee productivity. They enhance the customer experience. They improve the value chain. Robotics is good for business. Robotics is good for business. Robotics means money in the pocket of the organization. Robotic means, that organizations have faster return on investment. ROI is attained quicker. So this diagram really explains the advantages that we can see as far as robotics are concerned. So robotics are powered, but they can be powered by artificial intelligence and machine learning. And when they do that, then they become then they become artificial intelligence robots. When artificial intelligence is added to robot capability, it makes for a very good marriage indeed, because what you have is not just the appendages, the legs and arms of the machines. What you also have is the brain that does the thinking, where it might have been okay to just have a robotic bionic arm that just moved left and right. In this case, well, you can imagine if that robotic arm was gifted with a sensor or was gifted with a camera, and using the image grabbing features of that camera, it would know to avoid obstacles, it would know to avoid things that would damage it. That could be an advantage of when artificial intelligence meets robotics. Artificial intelligence and robotics, they are becoming the way forward. A lot of organizations are beginning to look at this as a competitive advantage. Artificial intelligence is the broad concept of machines and robots performing tasks that require very different levels of intelligence for humans to perform. So there are advancements in AI, as I said earlier, and robotics that have made the business of manufacturing to become better than it used to be. Outside of traditional tech-heavy industries, artificial intelligence and robotics are beginning to be used much more frequently as a union, as a couple. I remember working for Ford Motors in Essex, Dunton, years ago. And I remember some of the machines I saw in that Ford place were the biggest machines I've ever seen in my life. Machines as big as houses, my God. Machines as bigger than the triple, quadruple story buildings. I didn't know how these things could work, but they could work. And it has been so far traditional tech-heavy industries, traditional manufacturing industries, that robotics have been used. But more and more, artificial intelligence and robotics are fusing. There's an impact on the automobile industry, with artificial intelligence and robotics. Certainly, there's a significant impact on the global economy. There's an impact on the retail industry. There's an impact in working countries such as Japan, where they have more older people than younger people, as a solution to declining a working age population, because it has been a concern of countries such as Japan how to take care of the aging population. You can begin to employ the services of of robots in giving care to the elderly. So there's positive impact as a result of robotics. So let's attempt now to draw that diagram. I just felt, it's quite advantageous to give some sort of headline, of the area, not just start to construct a use case diagram. A use case diagram, it's all about the context. It's all about the domain. And if you fail to explain that, if you fail to, no matter how wonderful the diagram is, there's also learning going on by what I'm communicating verbally here, until such a time as you hear it and then you see it done. That information, that knowledge will not imprint in your mind's eye. So we are dealing with robotics. It has become a very interesting topic. It's that branch of technology that deals with robots. You can program robots to be able to carry out a series of actions, whether autonomously or semi-autonomously. Before you can deem something to be a robot, basically, number one, it has to be programmable. Robots are programmable. Number two, it's got to interact with the physical world via sensors and actuators. Number three, robots are usually autonomous or semi-autonomous. So these are three key factors that constitute a robot. So what we're going to do now is to begin to draw our use case diagram, and drawing that diagram will help put us in the picture. So you have this user here, somebody within the automobile industry, somebody within manufacturing industry, somebody within e-commerce and retail. Whatever it is, whoever it is, it's a robotic actor. So that person, we're going to call this person the robotic user. This is the person that triggers the task to be done. And so this person wants to, as a goal of the use case, carry out a task. Yeah? And sometimes that task, I want to introduce a new subject now. Sometimes that task could be a robotic process automation task. So a task that needs human input. You see, with robotics handles tasks that don't need human input. But a robotic process automation needs human input. I'm going somewhere. Bear with me as I write this down. So here, the goal of this particular use case is to automate repetitive tasks. Yeah? This is what robotic process automation would do. And it's going to extend the ability to carry out tasks. So remember I mentioned the nature of this relationship extends adds to the normal base use case. Not in all instances, there's optionality there. So if this user associated with this use case carries out a task, that task could need human intervention. And as a result, it becomes a robotic process automation task. It becomes a task that is a repetitive task. I think what I will also do here is to add RPA so that you can make that distinction. So this is going to be an extremely simple use case diagram, but it's quite a key use case diagram as well. Remember what I said about actors. The actors on the right, such as the one I've just created now, is called the secondary actor. That's a system that is used to realize that task. Because of the name of this use case diagram, we called it robotics. I don't know where it's gone to. Let's name it again. Robotics use case diagram. Yeah. So the robotic user has initiated the robotics system to carry out a task. What it does, what is that task? We don't know. That task could be lifting an object up from point A to point B in a manufacturing organization. That task could be, carrying out a diagnostic process in the COVID-19 ward. So in places like Dubai, they use robots as the interface between the doctors and the patients, because remember, it's a pandemic, and with COVID-19 taking place, when software robots are used to give care, there is less ability to transfer the virus. So what they are doing in places like Dubai, which is really taking the case of robotics to another level, is that they are using robots to deliver care that normally would have been delivered by doctors and nurses that would have been wearing PPE. So they're using robots to deliver care, and it's working out very, very nicely indeed. The Emirati government has only nice things to say about robotics. So this robotic user, the Emirati government wants to use the robot to diagnose COVID-19 patients. And what is the system that allows this to happen? The name of that system is going to be a robot. Yeah? It's going to be a robot. It could be a self-aware robot. It could be an artificially intelligent robot. It could be a non-intelligent robot. It could be an industrial robot. It could be a cobot, which is a collaborative robot, simplistically programmed to do A and B. Very simple, a machine with no intelligence, no brain. The reason why AI works so well with robotics is because if you see robotics as the body of the system and the artificial intelligence as the brain, if the brain is constructed and there is no robotic arm, robotic leg, bionic arm, robotic appendage, then all it's just an intelligent brain box. If you also have the body parts and the appendages created but not programmed with any intelligence, they're just pieces of metal. But the point at which the artificial intelligence is created and plugs and plays into the robotic physical items, well, that's called artificial intelligence robots. So these robots could be of very many different types. When you sign up to the course, to the internship course, either for the 10-day or 20-day, we'll give you the course, all of this course material that I'm busy building, that I have also built. It's not also only this. We have an LMS system. We have a Telegram group that you will join. We have a membership group where we have all our materials, our PowerPoint presentations, our source codes, where you get support, where you get your certificates of attendance. We have all of that. So when you do come on board, expect to get all of that. You can see that so far it's about 61 pages, this presentation. And I will continue to build it until I am extremely happy with it. So what you have in front of you is essentially the robotic domain. Very, very simple very simple use case diagram. Very, very simple use case diagram. Very, very simple use case diagram. Very, very simple use case diagram. So all the robotic user wants, and this is keeping it at 100,000 feet picture. We don't want to paint a picture that is too bulky, that is too much to read, that is too diagrammatic. Sometimes I see all types of qualities of use case diagrams. And when lines begin to cross each other, or when you begin to have too much abuse, when you begin to have the abuse of uses and extends relationship, then truly you need to consider whether the model you have constructed is the best you could have done under the circumstances. So this is a very simplistic view of robotics, but between this and the explanation I have given you, you can see how it works. You can see how it works. You can begin to see how the world of robots also work. So this is where I stop this teaching for now. And the next time we meet, I will be putting together the speech recognition use case diagram. So for now, we are happy to have gotten to this stage. So if you need these materials, if you want to join the internship groups, let us know, and we'll be sure to note the information down and also send you ample information. If there's one thing that we have, is plenty of material that we can give you that you can use during your learning and during your hands-on sessions. You get daily assignments, and those assignments will be marked. You get the source code, you get the PowerPoint presentation, you get the material, you get extra work, you get the opportunity for one-to-one interaction, to ask questions, not just of myself, but the rest of the faculty members, because I'm a veteran of over 20 years, and a lot of my other faculty members have a number of different industries and sectors that they have worked in as far as the AI domain is concerned. So by all means, you will also have the opportunity to interact with them, ask them questions, and get the opportunity of being handheld so that you don't make mistakes in the eventual places where you become employed. So thank you so much for being with me at this time, and I shall see you next time. Thank you so much. Bye-bye for now. Thank you.